Hello everyone. We've done so far from 1 to 7, and then the last week was a midterm, and today we're going to have a look how we get some outcomes from the VSIM micro simulation. In here, it's the printed in the 4, but there are heaps of outcomes we can get from the simulation run. So we're going to learn how to get our result. Okay, I just loaded the VSIM model that we created last week. Let's just get rid of the unnecessary network, and for the public transport, let's just leave it as it is. Okay. The first, let's imagine that you wanted to see how many vehicles is coming in and going through, going left and going right, and all these different directions as well. Of course, we put the vehicle input here. Right? Vehicle input of 500 vehicles per hour, and all these different directions. And also we assign the vehicle route as well. Okay, then we put it in what's the percentage to go to left, to go straight and right. Right? You still remember that? But when we run the simulation, it's not always like very deterministic way, because this is very dynamically changing. The situation keeps changing, and also, and I explained that last time, the simulation here in parameters, depending on the random seed number, the result keeps changing. Okay, so although we assign the vehicle route and route decision and the percentage of each directions, it doesn't really gives you exact number, okay, based on the vehicle input and the rate. So the time that we set up, based on the time we set up, we can keep evaluate what's really happening at the intersection. Okay, that's the things that we wanted to do first. So here, nodes. Okay, as you can see, probably this is all about the buttons for the outcomes, and we put in the nodes. And once you click that nodes button and it's activated, and control and right click, then you can draw that polygon. I'm sorry. Do it again. You can draw that polygon like that. Once you have, or by clicking the right mouse button, by the way, then once you finish it, this window pops up. Okay, and it says, yeah, please use for the evaluation. For the dynamic assignments, it's not used for this time, but sorry. This one needs to be ticked. And press OK. All right. Then there is a quick. If you look at the quick view for the nodes, then it's showing that that's for evaluation purpose. All right. Then it also says that it should return while visual or later. Okay. And once we create the polygon, then we go evaluation. Okay, evaluation, and there is a configuration. If we click the configuration, then you can see a lot of the it's called attributes here, but the outcomes basically. Okay, but each attribute has many different indicators in it. Okay, so it's not only, how many is it? Not only like 15, 20 attribute 20 outcomes you can get, but I think maybe hundreds indicators from those attributes can be retrieved. Okay, so now what they have done is for the nodes, right? So you go there and nodes collect data, you take it, okay, and time from 0 to the maximum basically, and the interval is you can assign what is the updating time. Okay, maybe if you wanted to evaluate every 10 minutes, then you can go 600 seconds. Okay, if you put more, there's some little parameters you can handle it, but let's say leave it as a default. So this means every 600 seconds you want to see some outcomes. Okay, press alright, and then right click on not these nodes, but we wanted to see the result of the node result, right? Node result. If we click that, then these parameters will come up. So these are parameters you can get, so what basically the indicators you can get from the nodes. Okay, you can see here that's a movement, maybe left turn, straight turn, right turn stuff, and queue length maximum, number of vehicles passing. If you have a pedestrians, that's a person's level of service for the intersection, and delay, stop delay, these and this is all the emission calculation too. Okay, so if you press that simulation run button, while the simulation runs, that's very slow, make it faster, and of course when it keeps giving us some numbers, right? And let's put this quick mode to go very quickly. Then as you can see here, it's 1000 seconds simulation run, and keeps running until 1 hour, which is 3600 seconds. Okay, let's wait a little longer. Alright, when simulation run finishes, and you can have this big table, gigantic table. If you look at here, for example, okay, that's a simulation run. We just run, only one time, so this is only one, and I put 600 seconds as evaluation interval. So we have a 600 and 600 to 1200, and hit this one, that one, and that one, right? So every 10 minutes, so you have 6 blocks. Okay, and here we see the movement. Each time interval or evaluation interval, we have got a lot of movement, right? Each direction has a 3 direction. So I've got 4. So this one, for example, it just say, I think from link 1 to link 2. I guess. No. There's one. So I think from link 2 to link 6, link 2 to 8, 2 to 9. Okay, 3 to 9, 4 to 1, 4 to 9, 5 to 8, things like that. So that's just showing the movement. Okay, so each movement, if that'd be nice if it's a syncing, if there's any visually available. I'm not really sure if it's possible, but maybe not. So this movement tells, okay, that movement tells there's somehow so let's say it's a 2-6, for example. This is link 2, and link 6 is this straight one. Okay, straight one it tells that queue length is a 5 or about 6 meters, and maximum queue length is a 32 meters back, and 44 vehicles passing, and level of service for the first 10 minutes is B, and all these indicators, numbers represented for all these indicators. Okay, that's very good. And it also automatically gives us some emission outcomes too. All these outcomes actually based on these indicators. There's some calculation behind. So based on those numbers, these numbers are calculated. Okay, very simple. So here we have a 1, 2, 3 directions. Okay, from here 1, 2, 3 directions, and summation of that, and 1, 2, summation of that, and 1, 2, 3, 1, 2, 3, and that one is finally for the entire network. That's the average values for that. So this one you can say for this intersection for the first 10 minutes level of service is C. Okay. The beauty of this, the Vissim can create some chart as well. Of course, this is not. That's pretty ugly though, because if you wanted to see some charts, you can drag it, right click, and create chart, and chart actually create for you. But basically, it doesn't mean anything, right? Because all these the parameters are all different. Okay, gives you very different. But if you use this smartly, for example, this is a only one movement from left to the right, from left to the right, to 6, to 6, to 6, but every 10 minutes, how it looks like. So you can create a chart. Then it's just showing you it's a bit mess actually, but it's actually showing you every 10 minutes how it's gonna change it. Right? There are many different ways that I think you can edit your graph, and you can put here. You can name the chart. There's some cosmetic ways of doing that, but the idea is same. All right, you can probably copy all these and open the Excel spreadsheet. If you're more comfortable with Excel spreadsheet, then you go there and you copy and paste it. Then all this information comes to the Excel spreadsheet. So from there you can, I don't know if you want to do that, but yeah, you can basically draw the graph if you want. Okay, it's all up to you. But outcomes coming out from this micro simulation. Okay, that is a node evaluation. Of course, if you have got many nodes, this is only a single node, and you can keep creating other intersections. Then you can have additional nodes. Then it gives you here 2 instead of 1. Okay, if you have a 2, like if we here, if you create another one, which is 2, and you run it, and you run the simulation, then here down, all the way down, and you can have a 2, right? Let's just stop it, and 1, and you have 2, right? 2, 1, 2, because you have now 2 nodes. Right, that's what it is. And then let's get rid of that. It's because it's a mess. Data collection points. For example, if you wanted to collect some data from this link, for example, then you have a right click. So I just created these 2 data collection points, then you have 1 and 2. Okay, this is where you put in the data collection point, and that's the position. Okay, that's the meter somewhere from here to here. This link from here to here is 210 meters. Once you put that data collection points, and again you go evaluation, configuration, and untick node, but instead we have a collect data collection. You click that one, press OK, and let's run. Okay, let's run, and let's just see what the data collection points provides for us. All right, go again the list of results and data collection results. Click. It doesn't give us any information, unfortunately. I think I needed to investigate what's really going on here. It should have some outcome coming out, since we do have these 2 points and it doesn't provide a outcome. I might have some mistake, but that is here the result attribute. You tick some parameters here, then you can see from the list and results there's many results that comes out. But somehow in this case, I don't know why, but sometimes must be reason. I might have some mistake. Then you go direct, not instead of this, you go direct output, and you go data collection, and then that's the raw data. Press OK, and you run it again. When the simulation run finishes, in your folder, because this time I don't see outcomes within the vSim, but I extract the result file into this folder. So let's just see. So simulation just finishes, and here this one .mer file came out. So you can open this any text file, text program. So in here you can see we have got 2 data collection points, right? And each data collection point, the car vehicle number 9 and vehicle type vehicle number 9, the ID number 9 has a vehicle type 100, because we have here in vSim at the moment with a normal car, a light vehicle, and heavy good vehicle. So it's different types. And here that's the occupancy, that's the queue, what's the vehicle length. All this information is here. Okay. And this one, the file name. If you look at the file name, since the vSim file, which is INPX, is week 9, the result comes out with week 9 underbar some numbers. These numbers is the number of runs we executed. Okay, that was the first time I executed, so it gives you 004. If you run now again, then it gives you 005. Okay, yeah, that's what it is. And travel time, of course, the vehicle travel time indicator is an important indicator. So you click, you make it activated, and you press any link that you wanted to get a travel time from. and you click, have a right mouse click, okay, and then you can see the pink one is here, and this color green, or very light green color is here. So from here to here, I want to see the travel time, for example. Okay, so if you, then this window pops up, and it's showing what's the start section, what's the destination section, and it's the distance between these 2 points. And press OK, and you can see a quick view. There's one vehicle travel time. Of course, you can have a multiple vehicle travel time. Press right click, and from here to there, and you have 2. You show the list. You have 2 vehicle travel time measurement. Okay, you go evaluation again. You don't need write to the file. Any result attribute, travel time. Is there any travel time here? Vehicle travel time. Yeah, vehicle travel time here. Okay. Then okay. Again, run again. And we go the list result and vehicle travel time result, and then it keeps update. As you can see here, if you put mouse move around here, then it keeps updating it, and it's showing us this one here to here, which is 1, and from here to here, which is 2. Travel time measurement 1, 2. It says that travel time between from left to the right is a 48 seconds average, and distance is this and that. Okay, that's the way you can get a travel time. But I'll give you some tip. If you go here, attribute selection, then window pops up. At the moment, the outcome here appears on the right hand side. Okay, so there are many other results as well here on the left hand side. If you move this attribute to the right, and it appears here. Okay, now and if you don't want to see such a thing, simulation run, for example, this is a simulation run, then you can activate this and click the remove. Okay, but if you wanted to see some other informations, for example, what's good information, maybe some delays. There are so many travel time. Travel time is every time is a difference, so maybe you can also want to see standard deviation. You double click, or either double click, or you can press this button to add. I don't know. There's so many informations we can get it from here. So delay, what's the minimum delay for all these information? There are so many informations we can get it from here. Okay, travel time evaluation is already there. Okay, that's good. Yeah. All right, so this is the way you can check what's the travel time between starting point and destination point. All right, queue counters, of course, that can be very important, right? So maybe you can go have from here, you want to see a queue count. Also, you want to see from here queue count, and it appears these 2 queue counters. And again, the evaluation configuration, if there is a queue counter and you can take the queue counter. Okay, that's the default values to calculate the queue counter. And okay, and you run it. Right, it's all same. And there must be list and result. There's a queue result. Okay, and the queue result is already some numbers comes up. Okay, This is where you can see what's the Q length, it's the Q length max, that's the Q stop. Okay. All right. So here, apart from these four guys, we need to assign some areas first, all point to point, right? But if you wanted to look at the some outcomes for entire network, yeah, that's very simple. Again, go here as a result, and you can probably want to stick the vehicle network performance, for example. Okay. Now, let's go one by one. Vehicle network performance. You press OK, and actually it gives you a lot of information. All right. List result, network performance, vehicle result, and you see heaps of informations here already. Let's wait until this simulation runs finishes. Done. All right. Then here, to say, if you hover your mouse cursor, it explains what they are. Here, for example, attribute the stop average. Okay, so that means number of stops for average number of stops. Oh, that explains it too. Average number of stops per vehicle. All right, and how to calculate it? And it says a total number of stops divided by number of vehicles in the network plus number of vehicles that have arrived. Okay, and there's average speed, delay stop average, distance total, travel time total. A lot of information is here. Okay, some information is missing because I think this is a emission. I feel like an emission outcomes only comes from the nodes. In this case, somehow. Again, let's have a look at this, and then have some calculation we can also put it into. And these guys are all the information that we can get from vehicle network performance. All right, that's very good. Let's, for example, fuel consumption. I want to see the fuel consumption at the end. Let's just see if it gives you some. Oh, it doesn't give you. I think there's some calculation missing. Yeah, but still there are a lot of information you can get it from evaluation configuration and then vehicle network performance. Here the area stuff is for the pedestrian. Okay, we haven't really learned the pedestrian modeling yet, so don't have to worry about it. If you want to get a network-wise delay, you can take that one link. Yeah, you try take there was stuff and check in the list after running. Then you can probably see what outcomes they are. And if you also wonder if you wonder what kind of outcomes you can get, and you can probably click the PTV with some help, and web-based manual comes up. Rather than that, let's see with some help. Then here evaluation. And here you can see some evaluations, overview of evaluation. Let's have a look at this. And all these information tells you what kind of results you can get. Okay. All right. Also, that is a in the configuration, you can tick anything you want here. And under the simulation, let's click the parameters. Here, this is where we can set up how many seconds you want it to run. At default, 1 hour is a default. So this is the reason why you can see 3,600 seconds, simulation seconds. And you can also set up the starting time, because normally in the modeling, we wanted to put warming up time. So if you wanted to evaluate 1 hour simulation, we normally give more time, something like that. And we start after 30 minutes runs in the simulation time, 30 minutes run, then we can evaluate it, okay? Because we wanted to load some traffics in the network already, all right? So that's what it is. And this is important. If you put simulation resolution 10, then the simulation runs evaluate every 0.1 second. Okay, don't mix it around. If you put it at 10, simulation runs every 0.1 second. Right? Look at this. This is 10. This is 10 now. When you run it, then here, this is the simulation second. Now 0.1, right? One more, 0.2, 0.3, 4, 5, 6, 7. So the time interval is a 0.1 second when we put this resolution as 10. But if you go with a 1, okay, then it goes every 1 second. Have a look. Now it's 1, 2, 3, 4. Okay? That's what it is. So even depending on the simulation resolution, result is a bit different. Of course, the simulation runs every 0.1 second or every 1 second. That should give you some different outcomes, right? If it doesn't provide you different outcomes, so why do we need 0.1 second? It takes a lot of time. If you wanted to save some time, okay, sometimes a significant time, then you put it in 1 and it runs a simulation every 1 second. Okay, and here I think the last time we already explained the random seed. This is a seed number for the randomness. Okay, so at default, I don't know why the sufficient like 42, but default is default. If you wanted to run like a 20 simulation runs, okay, if you put in here 20, and the simulation runs 20 times, and every time random seed number will increase by 1. So the first random seed number is 42, and second run 43, third run 40, 44, things like that. And once simulation runs 20 times, and it will stop. Okay, understand what I'm saying? So that's very, very important. Okay, important setup. Right. So for example, imagine now we've already run many times, so it's a bit messy here. But if you delete that result folder, okay, and you don't need all these files, right? And we run, simulation. Let's run it 3 times, and we put the resolution 1. So in a way, the simulation is very more quickly. And number of runs 3 times. Okay. Okay, and we run it. And let's wait. And once you finish this and second runs going, finish, and third run keeps going. Okay, stop it. And I should have deleted all the previous outcomes, which I couldn't delete it. But these three, 1, 2, 3, is the I just run the simulation, and here it automatically gives us average values for these three runs and standard deviation and minimum and maximum. So when we report our outcomes, we run them multiple times, like 20 times, then we give them a average values. Okay, because of randomness, exactly same input, exactly same network, you can see the delay, average delay is different. Okay, because of this randomness. So the safest way to report our outcome is they give them a average value of this, which here appears because this is 27 because of all these small number there, but average value, also standard deviation and minimum maximum. All these information is the right information for the readers. Okay, that's how you do it. And also the most important things for to control the simulation resolution is later we're gonna learn when we create some video. This the video quality will be depending on the simulation results. Simulation resolution. That is the things I'm going to explain later in a few weeks' time. Okay, but this is the things you can get some outcomes from microsimulation. Thank you for listening.